We are in Amsterdam. I will start with short, what I call the Amsterdam story, because surprisingly, OpenSIPS as history is quite tied to this place. And why necessarily? Because seven years ago, almost 7 years ago, on the Schiphol airport, I was on my way in August to Klukan, and I had like 7 hours stop in Amsterdam between flights to go to Chicago. And actually, in that 7 hours, while waiting for boarding to the Chicago flight, we had the first OpenSIPS release of 1.4. So surprisingly, it actually happened physically speaking here in Amsterdam. So there is a kind of a connection to this place. We wanted to have it ready for the Chicago event, and you know how it's in the development. You know, things are going back and forward. It's quite difficult to schedule everything. So yeah, we ended up actually doing it between flights. Yeah, planning is sometimes difficult, but you know, no challenges are actually stopping us in doing what we want. And the philosophy actually behind OpenSIPS, what was the reason for OpenSIPS to exist, is that we want to have a project for the user's needs. So the only thing that drives this project are what are the needs of the users. We look back through a lot of interaction by, let's say, mailing lists, by IRC channel, or whatever communication means. We look what users do need, and those are the kind of things that we do implement into OpenSIPS. We don't have any kind of secret, backstage schedule to follow and just make it public. So it's not like simply sharing the code, but actually we have the community leading this development process in terms of deciding what is relevant or not for the project to have. So it's a kind of a close circle between the OpenSIPS and the users, and we call it a project by the users and for the users. So actually the people do contribute with ideas, they do contribute with patches, code, they do contribute with testing, with support, or maybe they simply contribute by helping other people. So you already got a lot of OpenSIPS knowledge, and you go on the mailing list or on the IRC channel and help other people in terms of getting experience with OpenSIPS. So all these people do contribute to OpenSIPS. Ideas, code, what should be done, help, and so on. And then OpenSIPS goes back to the users with, let's say, the value in the code and in the knowledge, and help the users. And we don't want to be an open source project just because of the license, so the open stuff. It's not necessarily related only to the licensing model. It's also about our attitude to the users, like open to ideas, open to discussions, open to what should be done, and how to do things with OpenSIPS. And I think the most important things for the project, it's not necessarily to have an open source code. Okay, that's maybe the first step. But actually the most important is to have an open knowledge project. Because even if you have a great code doing crazy stuff, if you don't know how to use it, there's nobody to help you with that, basically that's a zero value project. And for us, an important part of this open thing is to share the knowledge with the community. And we do that by traditional means answering to the community questions in terms of providing in terms of questions like how you do that, and that and that. And I guess most of you are familiar with this kind of interaction. And I'm really glad to sometimes to get feedback or from various people saying, well, yeah, actually one of the main reasons we love OpenSIPS is the kind of help that we get through the mailing list, in terms of value and how fast you get such answers. Then we tried to put together a lot of documentation, tutorials on how to use it, because OpenSIPS as software is a very complicated piece of software. You have to understand the details, but also the big picture. Maybe you get to some, let's say, README files to understand the lower bits and pieces, like what this parameter does or what function this function does and stuff like this. But sometimes the most important is also to understand the big picture, like how do I do a specific scenario? So how do I implement like a call forwarding or I don't know what, So you have to understand first how the big picture and then to go into the details to make it happen. So we try to cover everything from we have the webinars, we have these tutorials. We do this kind of e-bootcamp trainings for the people who want to learn more things in details and so on. So everything, once again, when it comes to OpenSIPS, it's about this relation with the users. So everything is user driven. So the user by the users and for the users. In terms of let's say evolutions in these last 7 years, so from the Amsterdam event, we started, as I said, with the 1.4 version. That was the original OpenSIPS version, and this, let's say, trying to make some analogy, was more or less kind of a regular car. So it's a car. You have wheels, you have a wheel, everything like that. And what happened in the next year, like going for the 1.11 version, the development was more like focused on adding features, enhancements, maybe tuning some parts of the code, so under the hood things, like the design part. But at the end of the day, you can say, yeah, it's still a car, a different kind of a car, but it's still a car. So basically, let's say comparing with 1.4, this is the 1.11. But at the end of the day, once again, it's still a car. So you have the basic concept is the same. Something drives on the ground quite fast. You have a lot of options right now with the 1.11, but fundamentally, it's still a car. And the biggest so far the breakthrough was the 2.1 version, where we said, okay, we have to look further than simply enhancing what we have. So we have to, let's say, to rethink the whole design. And I'm not sure how many of you were aware of this internal redesign, which actually as a concept started like quite some years ago. But right now it made its way all the way to the, let's say, to the stable version, so into the official releases. So there was a lot of work done first in terms of experimenting things like new concepts to see if they are feasible or not, because we know that theory is theory, practical is practical. Sometimes they are not the same. So we have to actually be sure that whatever radical changes we do in design should have a positive outcome at the end. Even if on the paper looks great, we have to see exactly, when running on the heavy traffic, how it works. So basically, we come up with a completely redesign of OpenSIPS. And it's not anymore a car. Actually, let's say we got an extra dimension in the whole philosophy. So you are actually able to fly. It's 3D, but you are not 2D anymore like for a car. It's something more advanced in terms of design. We have more capabilities, and we will see. I'll talk more in details about that later. But now that we are on the way for the 2.1, so we actually start rebuilding a lot of things. And you know how you say, you get your appetite while eating. So once you start doing things, you cannot simply stop it. You keep going on and further. So let's say the 2.1 version, by the changes in this version, actually we open many possibilities in terms of what can be done in the future version. And even if 2.1 is just in the beginning of the 2.x branch, you know, it's the first one. We are already looking to the next, let's say, major redesign, or let's say next steps in the redesign, which is the 3.0 version. So we do plans for that, and let's say we see it again as a big jump. So getting off Earth. So we don't want to, let's say, we want to conquer another dimension further. And I will show you at the end, well, like ideas for the 3.1 and what would be the new expansion area for this version. But the main differences are that we are not simply looking for enhancement for performance, so enhancement in terms of performance or enhancement in terms of features, but to be able to have a completely different design, not for the sake of redesigning, but to be able to allow more and more things in terms of capabilities as transport protocols, in terms of interoperability with external applications, in terms of what you can do with OpenSIPS in terms of efficiency and so on. I will give you some examples when we will talk about the 2.1. So after this major 2.1 release, which actually happened on last week on the 7th of May, this was the stable release, because 2.1 as a release candidate happened somewhere in March this year, and there was like maybe 1 month and a half of testing. So probably there are a couple of people here knowing what I'm talking about. We had this bug hunting contest. So for people, we invited people to try to find as many bugs as possible into this release candidate code before actually moving to the stable version, which we think it's a kind of production ready version. Of course, nobody said that it's a 100% bug-proof version, the 2.1. There is no such thing when it comes to software. But considering the number and how radical the changes were in 2.1, of course, that intensive testing it's a key element for the success. So, in terms of what happens after this 2.1 release, the 1.11 will be the only version still maintained, because that's a long-term supported release. The old LTS 1.8, which actually had a long and successful line, came to an end. So the last 1.8.8, if I remember correctly, was the last release, minor release on that branch. And also the 1.10, which was a regular release, so it's not long-term, also came to an end while this 2.1 was released. So basically, at this point, we have two stable releases, the 1.11 on the old branch, which is an LTS, so will be maintained maybe for 1 year more, and the 2.1, which is the latest release. That's not an LTS, probably 2.2. The next one will be, because we are trying to get as much as possible feedback in terms of using 2.1, and probably there'll be like places that needs to be hammered and fixed and so on. So yeah, the decision was to have the next release as LTS. Now, diving a bit more in the 2.1 release and what this version has to offer for the community. First of all, as I said, it's the first version trying to go into the direction of let's say under the hood redesign in order to allow more and more interesting things. And this 2.1 is the first version actually taking benefits from what we call the OpenSIPS experimental. And that's a separate branch. It's not intended for, let's say, for usage. It's just a kind of I would say a kind of playground from the development perspective, where we tested different kind of concepts, like how to use, what's the impact of using asynchronous reactors, what's the impact of, let's say, using threads instead of processes, or what would be the impact of using for everything shared memory instead of private memory, and different kind of things like that. So that's a playground where we test concepts, and once they are validated technically and we see, yeah, that brings some benefit, then they will be ported to the mainstream code. So the 2.1 is actually the first benefiting from such, let's say, code injection from the experimental branch. And mainly, what were these benefits? Were getting this internal architecture redesigned based on asynchronous reactors. So basically, it's the way the tasks are internally processed to avoid any kind of wasting time. I'll talk a bit later about that. And also about new concepts when you have like a context for provisioning, so to simplify the coding, and to be able to do what we call execution resume, so to do jumps in terms of execution, so that you can pause and resume the execution for a certain package. And the first big let's say user of all these features is the asynchronous support that we have right now into OpenSIPS. Basically, it allows you to perform I/O operations from the script level into a non-blocking model. Out of curiosity, okay, first let me define what means I/O blocking operations. So they are like database queries, DNS queries, or maybe let's say radius queries. So basically queries to external applications, queries that you have to wait for an answer. So this waiting translates from the OpenSIPS perspective into kind of a blocking. And out of curiosity, let's see how many of you actually experienced problems, issues, outages, whatever you want to call them, because of such blocking issues. Doesn't matter what was the external application, but how many of you actually had problem with that? Well, okay, so that's a good reason for having the 2.1, you know, because right now we don't have no more I/O blockings. We don't say that's completely no more I/O blockings, but there is a first step. So we did the first thing, the first approach was to do it at the script level, so for the operations from the directly from the script, like when you run an, let's say, an SQL query using the AVP DBOps module for triggering external scripts applications. So in all these cases right now, you don't block anymore. I mean, OpenSIPS will not block anymore. It will keep waiting, but in a non-blocking way. While waiting, it will be able to do something else, to process other messages instead of simply blocking without doing anything. Because the main problem with this is blocking. You have processes blocked in waiting for something, so you are not able to take any more traffic and handle. So you may end up discarding traffic just because you are waiting for, let's say, a DNS query or for a slow MySQL server and so on. So this is the first support for the asynchronous IO operations, and actually we have later a workshop today on that. So where Livy will get into the details how to actually use it from the script, and it's interesting to see actually the effects of that, you know. So instead of going through the blah blah what IO means and blocking and so on, to see some real the difference between the two things. And I tried here to, let's say, to get a graphical difference between the two approaches. Like you have the synchronous operation. You have one kind of thread of execution, and there are various tasks that may require waiting. So you can see here that you have you have gaps in terms of execution because you are simply waiting. So basically that thread is not able to do anything else because it's sitting there and waiting. While in asynchronous mode, whenever these gaps are actually filled in with other tasks which maybe do not require blocking. So let's say you handle calls, and we know that maybe 90% of the effort in routing calls is done when you do the invite, because you have a lot of logic. You have queries to see user profiles, maybe you do DNS queries and so on. So you do a bunch of queries and the effort in terms of processing just to see where you send the call. Once you did that, you know, the rest of the actual call, the ACK and replies and byte, they are simply SIP routing. They don't require any kind of extra, let's say, logic, aside standard SIP logic. So when you do a lot of waiting and processing the invites, what actually OpenSIPS will do right now will be able to handle packages like for ACKs and bytes, reinvites and stuff like that. So a lot of tasks which actually do not require any kind of I/O operations. So that means in the same time interval, you know, a single thread will be able to handle more packages than in a synchronous way, because probably here you'll have like 30–40% of the time simple wasted in sitting and waiting. Now that time will be reused for doing some other kind of tasks. Another area where a major rework was done was in the transport protocols. And let's say to make it short, we said yes, we want to, once again based on the feedback from the users, we have this monthly meetings on the IRC channel. It's the last Wednesday of the month, and we have different kind of topics. It's the way of getting feedback and interacting with the community. And somewhere last year was a discussion about, okay, what should be the approach in regards to WebRTC, you know, in terms of OpenSIPS. Should we do it? Shouldn't? And so on. And there was a meeting, and the conclusion was yes, if we can do it in a proper way, let's do it. But if we end up with a kind of a, I'm not sure what was said. I think it was I think it was Eric from OpenSIPS. He said, okay, if we end up with a kind of a Frankenstein code, better not do it. Because the idea is adding new transport protocols in the 1.x, let's say, releases, it actually was not an easy one. Because the protocols were all of them hard-coded directly into the core. So they're not separate entities, it was kind of a spaghetti code. So like adding or reusing parts of the code was like, oh no, rather shoot myself instead of doing that. So we had the, let's say we were facing the dilemma of, okay, if we do it on the with the old code, like adding like WebSockets transport protocol, it was like, oh my god, we end up with Frankenstein. So in order to do it in a nice way, we end up reworking all transport protocol support in OpenSIPS. We created two levels. Basically, the lower level, which is related to the actual network transport, basically UDP and TCP. And then on top of this kind of a network transport, you said, okay, we will put the CP transport layer, which can be, let's say, for the TCP, you have the TCP plane, you have the TLS, which was already existing, and also that TLS was a big problem about compiling. Had TLS and non-TLS version, just because the TLS had to be compiled into the core, which was really pain. And then, of course, WebSocket is also on top of TCP. So for all these CP protocols, you had to have exactly the same kind of code for managing the TCP connections at the network level. So that's why we ended up with this kind of design, where you have the basic protocol, network protocols, UDP and TCP, and then on top of them, you can actually add standalone modules. So these are like SIP modules. So right now you can dynamically build new protocols through these kind of interfaces. On top of UDP, you have the CSTP and plain UDP, and God knows what in the future. Or for the TCP, we had plain TCP, the TLS, WebSocket, and so on. So basically, just because we wanted to do that, but the idea was to do it in a proper way, you know. So maybe we want to add new kind of protocols in the future. We had to rework everything. So these are like existing code. You know, support for CSTP, UDP, TCP, TLS. So we end up with a massive rework of code just to get to this, and then say, yeah, okay, now we can add WebSockets in a very simple and nice way. So when you will deploy the 2.1, you will see that for whatever kind of a protocol like you want to use for the SIP listeners, you have to load as a module the corresponding module. So if you want to have like a UDP listener, you have to load the Proto UDP module, the Proto TLS or the Proto WebSocket and so on. And this solves a lot of problems. First, being modules, so you can scale all the in terms of protocols, code reusage, because all these actually relies on the TCP layer in terms of managing the TCP connection from the network perspective, which is quite a nightmare when you have a multi-process application, so you have to pass connections from between processes. And being standalone, we got rid of the problem like we had with the TLS, because some protocols do rely on external libraries. So that's why before we had the OpenSIPS TLS and no TLS. The TLS one was compiled against the OpenSSL library. Right now, the core is completely independent. So only the Proto TLS module is now compiled against the OpenSSL library. So it's up to you if you want to use it or not. So you get some big advantage in terms of modularity when it comes to installing, compiling, and everything. And okay, after we reinvented the world of transports in OpenSIPS, we said, okay, let's do the web socket support, the server side, because that's what's required for the WebRTC part. And yeah, as you saw in the diagram, the WebSocket module is on top of this TCP code, and it allows OpenSIPS to do WebSockets to standard SIP gateway. But keep in mind that OpenSIPS does only signaling, so it takes care only for this part. And to have a fully flavored WebRTC solution, you will need also to take care of the media part. And for that, there is a successful integration with the RTP engine, which is able to do the gatewaying for the media. Razvan will show tomorrow in a workshop about how to deploy all these for OpenSIPS. Basically, let's say that's the WebRTC diagram. You have the browser. That's the new part. So that was the part which was missing into the OpenSIP. So basically, conversion from WebSocket to regular SIP. So right now, all the clients, whatever SIP client you may have embedded in the web pages, it will connect directly. So this will be on OpenSIP. As I said, for the media, you have to have this media server to convert from WebRTC to RTP. Actually, it's SRTP on this side. So you have to switch to RTP because most of the gateways or SIP clients, regular SIP clients, do not automatically support SRTP, which is mandatory or ICE, which are mandatory into the WebRTC work. But once again, OpenSIPS takes care of all these things, and here we have this RTP engine, which is able to do the media part. Also in 2.1 we have some rework of major modules, modules requiring a lot of, let's say, data. Usually there are modules taking care of routing, like dynamic routing, downplan, dispatcher, and so on. And even if you have, like, for all these modules, sets of data, so you can have a set for, let's say, dispatcher, you have a set for dispatching over your gateways, dispatching over another set for dispatching over the media servers, and so on. Still, we hit a limit. So going and building platforms for different kind of services, we personally ended up with a dilemma of actually requiring multiple, let's say, dynamic routing instances. For example, we have a whole set of data in the dynamic routing for doing routing to the gateways, right? With its own sets, different kind of gateways, different kind of routing, different kind of routing logics, and so on. And in the same time, we say, yeah, we want to use the same kind of dynamic routing set of data, but for billing purposes, like identifying prefixes, putting charges on them, and so on. So first we ended up with a funny situation. We simply cloned the module. So I have like derouting and derouting 2 and derouting 3 and so on. So just copies of that module with a different set of tables. But definitely that's not a nice way to do it. You know, it doesn't scale. And that was, how to say, ugly hack. So we invented the concept of a partition for all these modules. So basically, the module is able to clone itself virtually, still the same module, but from data perspective, you can create different instances of data. So you know, you can have all these modules working on multiple sets of data for different purposes. So gives you more liberty in terms of building services. A very important module available right now in 2.1, the fraud detection module. And OpenSIPS had so far a lot of capabilities in terms of, let's say, security, server-side security. You know, you can do detection for floods. You can double-check authentication and all these kind of things. You can check routing, sequential routing, and so on. But still, there is one vulnerable place in your platform still left exposed, which is actually the end user. I know that many of you do operate different kind of OpenSIPS services. So, how many of you have had hijacked clients? So, let's say having asterisk PBXs hijacked and injecting them calls, or okay, so that's really an issue. You know, even if you can say, you know, from a service provider, say, hey, it's not me. I mean, you got hacked. You know, you as a customer. But sometimes you have to do something for that. You know, it's not the kind of an answer that you want to give your customer. I mean, it's your fault, not mine. So, okay, this new fraud detection module actually is addressing this kind of a problem in 2.1. And how it works is simple to explain, difficult to implement. How it works is you define some kind of profile, like a calling pattern for your subscribers. Like what are the prefixes they usually dial? What's the day intervals they use to dial? Like, okay, these clients should dial only during working hours because they are like maybe enterprise accounts. So they should not make calls during the night, or they should not make calls in the weekend. Or what's the limit in terms of calling rate, like calls per minute or parallel calls. And so you define such profile that you can assign to your users. So whenever OpenSIPS sees on suspicious activity meaning something not fitting into that profile. Like you have the enterprise customer, and then suddenly during Sunday it places a lot of calls, maybe like with a rate of 3-4 calls per second to some, I don't know, crazy Pakistani destination. You know, these kind of highly charged numbers. So that's automatically an alarm from OpenSIPS. It will, based on the profile, will detect this suspicious behavior, and it will be able to report it, let's say, to whatever kind of mechanism you have. So the module actually is doing the detection and reporting. It's not taking any further action. That's up to you. Like maybe you want to block, automatically change password on that account or whatever, you know. But the good part is that you have something automatically looking for your users. So the protection is basically checking if the user does something suspicious or not. So suspicion meaning maybe that account was hijacked in terms of password, in terms of IP or whatever. So you can build different kind of profiles. You can assign the profiles to the users, and then OpenSIPS will simply monitor the activity. And whenever it's something strange, it will simply report as an event. And then you can manually double check, or you can hook it to the automatic system to block the account. It's up to you. But the idea that if you have the possibility to do it automatically. Another interesting feature, which was a result of, I would say, user complaints, the SIP compression. How many of you had, let's say, issues because of UDP fragmentation, like losing half of packages and so on? Okay, so we see some hands in the air. Well, this SIP compression actually touches two important aspects in terms of minimizing the SIP traffic. First is about compacting in terms of SIP-wise, traffic. So basically moving from regular header names to the short version or combining headers with the same name. So we have like via, it's just making one via header with multiple bodies. Or you can filter out unwanted, unnecessary headers like timestamp, subject, or stuff like that. That same 90 dimensions of SIP, which sometimes they don't do anything. So you have a lot of possibilities to actually reduce the size of the package. So whenever, let's say, you send a package to the endpoint, you can do this SIP-wise compacting of the package in trying to get, let's say, to reduce the size and to avoid the fragmentation. Of course, there are some even more aggressive ways of doing it, so not like SIP-wise. Actually is about compression in terms of taking non-routing essential information and compressing it as an archive to a SIP as a SIP body. And this is very, very helpful when let's say you have a platform where processing the code requires, from SIP perspective, to go through multiple hops. Let's say you have an SBC in front, then you have a routing, then you have maybe some register server, and then you have some, I don't know, PSTN engine, and then again an SBC at the end. So basically your package goes through like 3 or 4 instances of OpenSIPS. And usually, because of service separation, because of geographical redundancy, and many other reasons, you may end up with such platforms. So, according to some profiling we did some time ago, in OpenSIPS, maybe I think 40 to 50% of the CPU usage is done for parsing and building the SIP messages. And because in order to process the message, you have to parse. And unfortunately, SIP is quite, how to say, unfriendly when it comes to the syntax. So it has a really, really, really complicated syntax. And if you have long packages, then of course this parsing and building effort will increase. So the philosophy over here is once the package gets into your network, you can simply strip headers which you are not interested in, keep only the things that you need for routing. You put in, let's say, in an archive, kind of a zip archive, so it's compressed, and that's attached to the message as a new kind of a type, body type. And in that case, you drastically reduce the size of the parsable message, or the part that needs to be rebuilt. So if you look at the overall the platform, you may reduce even with the 30–40% the CPU usage because of unnecessary parsing. Like keep parsing and parsing and parsing in different places the same SIP message. So just keep whatever is essential for processing, and the rest of the things that need to be simply carried for in and out, you can dump it into the body, which will be simply ignored, into a compressed way. And of course that also reduces the bandwidth because it's compressed in a binary format, so it will take less bandwidth to go through your servers. These are the 2 important things that you can do with SIP compression. The SIP-wise reducing of the package, and also compacting, usually done inside platforms by adding moving headers into the body payload. Another interesting addition to the 2.1 is the quality-based routing. Because so far you do kind of a static kind of routing. You do like a prefix-based routing, balancing, and things like that. So basically you just do it based on static things, prefixes, the capacity of the endpoints, and so on. Well, probably when you deal with carriers, you learn that carriers are quite unpredictable when it comes to the quality. quality translating in what's the response time in accepting calls, what's maybe the media quality, and so on. And what this module does is it learns about the quality offered by the carrier. So during runtime, learns about such information, and it's able to change priorities in terms of routing to favorize, of course, the better quality carriers. So module is collecting a lot of information from the calls, like what's the ratio of answer call, what's the post-dial delay, and other kind of information. Maybe in the future we will expand to get also RTP statistics, so to look into the media. But it collects the information generically about the call's quality. So it knows that a certain gateway has a certain quality in terms of handling the calls. And then it will start reordering in real time, let's say for a certain prefix, let's say termination to let's say to India. You have some carriers, you have a prefix and you have multiple carriers over there. Some carriers may may provide good quality during the day, some other during the night, and sometimes it's completely unpredictable, like when they have good quality or not. Maybe depends on other customers that the carrier has. So you can put all the carriers in there for the, let's say, for the India prefix, I don't know which one is, and then let the quality-based routing module to keep reordering that carriers for that specific prefix based on the quality in real time. So the module will analyze the calls, will learn the quality for that gateway, and will all the time use first the gateway with the best quality. So you don't have to go by hand and let's say reorder, do reload, and things like that. So the module can automatically do it for you. Once again, looking at various parameters of the calls defining the quality. And one of the last but not the least contributions to the 2.1 is the emergency calling module. Well, probably all know already when you implement a VoIP service, you have to handle the 112 or 911 calls according to the local legislation. And this module is trying to address this problem in an encapsulated way. So, looking at some RFCs saying on how such emergency calls should be handled. Also, it looks at the I2 specifications from the Association of National Emergency Numbering, the number association for North America. Basically, they say how this call should be handled in terms of finding who's the caller, finding the local, the closest emergency point where the call has to be delivered based on, I don't know, a lot of other properties. So basically, okay. Oops. Oh.
Feature. Nice job.
Yeah, that's what happens when you use free. You know, I forgot the magic to trick the beamer to.
Move the main window to the other screen.
What?
Start the presentation. Move that window to the screen on your laptop and then start.
No, that's just the beamer is doing that. It's not actually the screen.
What happens if you click exchange?
No. Well, anyhow, there's one slide left, so hopefully we can manage. We are technical people, but some things are really secret. Well, that's a really complicated schema. How to say, it's beyond regular understanding on how this emergency call routing works. It's basically about handling the zip code, going to some regional centers where these emergency calls, geographically based centers, where these emergency calls should be handled. There are like a couple of redirect servers, SIP servers involved, servers that knows about these locations, about the users, profiles, and stuff like that. So from OpenSIPS perspective, there are like three scenarios that can be used, like simple routing the call, or acting as a dispatcher for the emergency call, so supplying information about where the call should be landed. This is the emergency service provider networks. So it's the traditional, let's say, base where the agents answering to such calls do sit. So yeah, this emergency calling module do offer in an encapsulated way all this logic for routing these kind of calls. And yeah, before ending, a couple of short things about what are the, how to say, long terms for things for the OpenSIPS 3.1. So we are looking for to finalize this quality-based routing, because actually the module was developed for 2.1, but it's not part of the official release. So it will make it probably in the next ones, mainly because there was some unfinished integration work with other modules. Because this is what happens when you start, let's say, refactoring code from like maybe 4 or 5 directions. At the end, somebody will lose the fight, and it will have to rework again his code just to fit with the other people's changes. So basically, the quality-based routing was a victim of all the refactoring that happened in 2.1. So the module was originally ready, but after we refactored all this transport and the dynamic routing partitioning and so on, we discovered that, okay, it doesn't fit anymore. So it was held back for the next releases because, okay, we need to redo certain things over there. An important thing that we want to do is config file refactoring. And this was triggered mainly because of all the changes we had into the transport area. A lot of parameters moved from core parameters into modules, because the protocols actually became modules. So let's say whatever was TLS oriented parameter ended up right now in the Proto TLS module. Similar for the TCP and so on. And you know, while addressing this kind of issues, we said, hold on. You know, if we want to have a lot of things which are module oriented, we look for things to simplify how you actually handle the modules from the script perspective. Like, okay, you have to load the module, you have to define a lot of parameters for a single module, and so on. So we want to look at how to simplify the scripting in terms of make it more simpler and intuitive to work with. Because we learned that sometimes you have to do kind of a trade-off between the flexibility of the script and between how simple and straightforward it is to use. For example, the grammar right now allows you actually to, probably nobody tried to do so, but you can actually have, you can put some routing blocks, and then somewhere somewhere in the middle of your file, you can put some global parameters, start again with other routes. You can put again, let's say, other global parameters at the end. So basically the syntax allows that, even if logically it's broken, but the syntax allows. So, because of that, you may have a lot of, how to say, some kind of issues with handling the modules. For example, there is the well-known module path parameter, the mPath parameter, telling OpenSIPS where exactly the modules are located. Well, the script right now doesn't give you any kind of dependency between that parameter and actually loading the modules. So you can put all your load modules in the top and put at the end of the script the mPath, which basically, okay, syntactically is correct, but will have no effect. No, we'll just put it at the end. So which is a bit of a, how to say, makes no sense, right? So, we came across such problems when we had to handle the loading of the module for the transport protocols. And we said, yeah, okay, we need to look a bit into, simplify all these things about loading modules from a syntax perspective and also from, let's say, simplifying things. So that's something that probably will be a discussion topic on one of the next IRC meetings. So to see what's the opinion of other people in this perspective. Then we have, actually this is already done in the trunk, in the development branch, the SQLite support for the database backend. We have, there was a quite, let's say, huge demand for that because it's a very light kind of a database. Basically, you don't need a server, so it's if you have light deployments, it will make a perfect choice for your DB backend. And while we were refactoring all the transport layer, we come across problems about, let's say, what we generically call the edge proxy support in terms of TCP connection reusage. Probably Damian here can say many things about that. There were a lot of complaints about that in terms of how the code works. So about connection reusage, about routing traffic through an edge proxy, maintaining the state of the connection, about NAT reversal related things, and at the end of the day, all these things somehow do interact. They do depend on each other, because if you think about TCP connection, like the reusage and the NAT reversal, and all of them fall in the same bucket. Like you address some network layer issues that needs to somehow fit the SIP layer. So we are looking into finding a unified and also integrated way of handling all these problems into OpenSIPS. we want to go further with the WebSocket in terms of, okay, first adding the WebSocket secure transport. So that will be probably an easy one. Would be simply extending, reinvent and hack everything. We just create a simple new module for that. We're using maybe half of the WebSocket protocol and WebSocket client side. Because as I said, for the WebRTC, you need only server side, so just to accept connections. That's the typical setup. Well, we are looking one step ahead, and we want to use this WebSocket protocol for, let's say, some future needs in terms of integrating OpenSIPS with other application, or even with OpenSIPS to OpenSIPS interaction. I'm not sure how many of you are familiar with the binary interface, which is used for replicating internal state for registrations for dialogues. And that one currently works over UDP, because in day 0 that was, let's say, the best decision, but it has some limits in terms of, UDP is not reliable shortly, so you may lose packages even on the internal networks. So we look to shift to something like TCP based, and maybe WebSocket is one alternative, because it also give you like, on top of regular TCP, it gives you the package size, so that simplifies a lot the communication. So if we want to shift, let's say, the binary interface to something like that, then of course you need to have both ends, server and client side for the web socket. And we are not, once again, limited to the OpenSIPS to OpenSIPS communication, but also being able to talk WebSocket with other external applications. So that's also something that we look for, mainly. Clustering user location. That's once again a very hot topic lately. How to create clusters of OpenSIPS to share in different ways the registration information. And even if it's a hot topic, all the time was unanswered, or let's say uncompletely answered. Mainly because we have so many scenarios in terms of clustering and registration that basically at a certain point it's impossible to come up with one solution fits all. Because sometimes you may are the TVs working or no? No. So clustering may be like sharing, or simply partitioning, or let's say sharding in different ways. So you may want to have independent locations simply talking one each other just to know exactly where the user is registering, or you want to have a full exchange of registration information between the servers and so on. So that's why we are not so far able to come up with a single solution to address all these. But we said, okay, at some point we need to start from somewhere. So we will start talking, coming up with several proposals on how to address this issue, and to start to work from somewhere. And of course, more asynchronous support. Looking into having support for the TLS layer, mainly about connecting the TLS streams, and also in because it's quite popular in use in Radius, so to have Radius support in asynchronous mode. And we already have someone hacking the libradius, the Radius library, to be able to support asynchronous operation on top of it, because in that case it's not only about OpenSIPS but also about the Radius library. Fortunately, Radius is quite simple, works over UDP, so it would be quite. It's like 80% work done in that area. But one of the most important things about the future directions is about implementing support for application server in OpenSIPS. And basically what that means is we want to make, first of all, OpenSIPS quite friendly in terms of integrating and talking to other applications, like passing the call control or passing the routing decisions to external applications. So OpenSIPS doing SIP-related routing, but in terms of where to send or what other kind of things to do. So such a decision may be taken by other applications written in whatever kind of language. So we want to offer alternatives to the current OpenSIPS config file, because the first impression right now, for a user looking at the OpenSIPS, oh my God, what's that? What is config? No, not again. I don't want to see that. So they really get scared about that. So using a kind of application server front end to give you the ability to control and integrate with your own routing logics, the OpenSIPS, without getting your hands too low into the let's say SIP size. Also interconnecting and let's say interfacing with the external application that are providing additional services for OpenSIPS. Dan is the next speaker, and he will show you how to use, for example, the billing engine, like how to integrate, and he has more or less the same kind of problems when what's the best way to make OpenShift talk to the billing engine in terms of authorizing and authenticating and all the things related to the billing, keeping a control over the code and things like that. So these are real problems, and what we like to do is, instead of simply jumping and saying, yeah, okay, we will do it, we try first to understand the big picture and come up with a consistent solution. So not like simple hacks here and there, just to make happy, let's say, scenario A or scenario B, but with a solution that in long term will make happy as many scenarios and many users as possible. So this, I think that would be the, let's say, the jump from a helicopter to the rocket in terms of OpenSIPS. So the ability to control it and integrate it with other applications which you may already have, or third parties, and so on. So well, that was my presentation about OpenSIPS, trying to go from the origins, focusing on the 2.1, which is, let's say, the major release and one of the most representative release for the OpenSIPS community in terms of what we want to do and what's the philosophy of the project, and also looking a bit ahead, or in terms of what we want to do in longer terms. So basically, listening to the needs of the users and trying to put together things and come up with some nice solutions in terms of coding approaches and so on. I hope it wasn't a too boring presentation. You know, I will have my colleagues actually showing, let's say, more interesting things in terms of workshops on how to do real things. You know, that was just a kind of an overview. So they will have the pleasure to get into more details with certain scenarios. So thank you for listening, and yeah, I'm almost in time. So thank you. If you have any kind of questions, I'm not sure if we have time right now, but you know, otherwise I will be more or less around here for the whole event. So thank you.